Hello everyone and welcome to my presentation. My presentation topic is Digital Parking Control System, and this is instructor by Nafis Ahmed Chistri, Associate Professor Head, Department of Tripoli, and this is submitted by Mohaimenul Haque, and I'm going to next slide now. Now problem statement. We have to design a parking system that will have seven parking spaces, and will have to display full when the garage is full, and space available when the display will be blinking. And the key components we are using here is 3-bit counter, 555 timer, and FSM. The next step is block diagram. Here we can see at first we have entry sensor, then 3-bit counter, and then comparator, and then time circuit, and then 7-segment display. And then we will use exit sensor, and then we can see that here is max capacity is 7 cars. Now I will explain the flow diagram. Here we can see that at first start, then initialize counter, and then monitors the sensor, and then we are using a loop, and then update the count. For count, entry +1, exit -1, and then we will check the count, and then if the count is equal to 7, then yes, display will be full, and if no, blink, space available. So the thing here is if the count is equal to 7, then the display will always be saying full, and then if there is 6 or less than 7, then the space will be blinking, and the user will see that there is enough space here. For 3-bit counter design, we use JK flip-flop down, up and down counter, and the truth table here is if we use here entry as 1, then the exit will be 0 and action will be +1, and then if we entry 0 and then exit will be 1 and the action will be -1. In our problem statement, we are using 2 timer circuit, and here we are using timer circuit 1, and this will display full, and the configuration here is 555 abstract mode, and the components we are using here is resistor 1 is 350 ohm, and resistor 2 is 392 ohm, and the capacitor we are using here is 250 μF, and the output continuous is high theoretically. The timer circuit 2 here is blinking display. The thing is, in timer circuit 2, we will be using some LEDs, and that will blink and show the user that there is space available. And for this, the parameters here is duty cycle D is 66%, and so the P is 34. Frequency here is 5 Hz from my ID, and the components here we are using resistor 1 362 ohm, and resistor 2 392 ohm, and the capacitor we are using 250 μF also. The next step is FSM design. To design a FSM, at first we need a state diagram. In a state diagram, we are using at first start and then state A. For state A, we are using 1, and for B, we are using 0. And then for state B, we are using A is equal to 0, B is equal to 1. And the time limitation we are using for TH and TL are both 4 ns. And the Verilog snip here is if count less than 4, A is equal to 0 and B is equal to 0, else A is equal to 0, B is equal to 1. Limitations and improvements. By doing this work, we have some limitation, and after completing my task, I thought that there will be need some improvements also. The limitation here is max capacity of the car is 7, is very low, and we are using only 3-bit limit, and no sensor error handling. So if there is a error, the full system will be collapsed and not will be using. And the inputs here we need is 4-bit counter. If we use 4-bit counter, we can add a LCD for real life timer counter, and the users will be see the how many cars are in the garage and how many space are available. Now we are in our conclusion, and the conclusion here is we successfully designed a parking system with car counting 3-bit and dynamic displays full and blinking and FSM control. But if we want to upgrade the system, we have to use a 4-bit counter, and we can use a LCD screen, and this will help the user to understand clearly.